Hello everyone. Today in this lecture I am going to discuss the building blocks of UML, Unified Modeling Language, conceptual model of UML. So the building block of UML contains three type of elements. They are things, relationships and the diagrams. Unified Modeling Language is a general purpose modeling language in the field of software engineering, which is designed to provide a standard way to visualize the design of a system. So the building blocks of UML contains three types of things. They are things, relationships, diagrams. So what are the things in UML? UML includes four kinds of things: structural things, behavioral things, grouping things and annotational things. Okay. So first of all, we will discuss the things. Structural things. These are the mostly static part of the model, representing elements that are either conceptual or physical. There are 7 structural things in UML. They are classes. First is class. What is class? A class is a collection of similar objects having similar attributes, behavior, relationships and semantics. Graphically, class is represented as a rectangle with 3 compartments: class name, attribute name and the operations. So here it is shown in the figure. So first of all, what is class? Classes are a set of objects which have similar responsibilities. So class name, attribute list and the operations. This is the first structural thing in UML. Now the interface. What is interface? Interfaces are set of operations which specify set of classes. Okay. So an interface is a collection of operation signatures and oblique or attribute definitions that ideally define a cohesive set of behavior. Graphically, interface is represented as a circle or a class symbol stereotyped with interface. It may be in the form of a rectangle and divided into different sections. First section is in write the name of interface within 2 left right angled bracket and 2 right angled bracket, interface name, and in the last field there are the do method, string, void, init, boolean, long, boolean. These are the data types and the methods. Okay. Now the collaborations. A collaboration is the collection of interactions among objects to achieve a goal. Okay. So it is graphically, collaboration is represented as a dashed ellipse. As a dashed ellipse. A collaboration can be a collection of classes or other elements. So we can say that collaboration extends both the behaviored classifier and the structured classifier. Okay. To explain how a collection of cooperating instances achieve a joint task or a set of tasks, its primary purpose is to explain how a system works and therefore It typically only incorporates those aspects of reality that are deemed relevant to the explanation. So a collaboration describes a structure of collaborating elements, roles, each performing a specialized function which collectively accomplish some desired functionality. That is task. Details such as the identity or precise class of the actual participating instances. So collaboration name, in collaboration it is represented as a ellipse, dashed ellipse. For example, if there is in there is doctor and there is patient and they are connected through some connector, and the collaboration name is visit, and the collaboration name for this example will be visit. Patient will visit to the doctor, and the role is doctor, role type is doctor, role is patient, there is connector, and what is the collaboration? Collaboration name is visit and collaboration is doctor to patient. Okay. Now use case. What is use case in UML? So a use case is a collection of actions defining the interactions between a role, that is also called actor, and the system. Graphically, use case is represented as a solid ellipse with its name written inside or below the ellipse. So the use case is represented in this form. Next is active class. A class whose objects can initiate its own flow of control, and flow control is also known as threads, and work in parallel with other objects. Graphically, active class is represented as a rectangle with thick borders. So here it is shown in this figure that this is the active class with the thick rectangle border, and in this there is class name, there is attribute list, and there are operations list. Now the component. What is component? Component is a physical and replaceable part of a system. It can be replaced, and one more property is it is physical. So graphically, component is represented as a tabbed rectangle. Here it is shown is a rectangle and there is tabbing. Example of components are executable files, DLL files, database tables, files, and the documents. We can say a component in the unified modeling language represents a modular part of a system that encapsulates the state and behavior of a number of classifiers. Its behavior is defined in terms of provided and required interfaces, and it is self-contained and substitutable. Okay. Now next is the node. A node is a physical element. Node is a physical element that exists at runtime and represents a computational resource. Graphically, node is represented as a cube. Example of nodes are personal computers, laptops, smartphones, or any embedded systems can be the example of nodes. Now the behavioral thing. Behavioral things represent the dynamic aspects of a UML models. Behavior of a UML model can be modeled as interactions or as a sequence of state changes. There are two primary kinds of behavioral things. One is interaction and another is state machine. So first is interaction. A behavior made up of a set of messages exchanged among a set of objects to perform a particular task. A message is represented as a solid arrow. Below is an example of interaction representing a phone conversation. Now, here is caller. In middle it is phone system and there is a receiver. So first caller picks up phone system. This is the interaction diagram. Here it is shown how the process will work. So first caller picks up the phone system. Then after that there is dial tone. After that caller dials number. If it is correct, then phone system will ring to the receiver. After ringing, there will be pickup process and the receiver will start the conversation to the caller. Both are in the conversation and there is hang up. If any one of the party wants to disconnect, they can connect. Okay, so this diagram shows the interaction diagram. Now the state machine. A behavior that specifies the sequences of states an object or interaction goes through during its lifetime in response to events. A state is represented as a rectangle with rounded corners. So in below is an example of a state machine representing the states of a phone system. So what can be the states of the phone system, telephone system? So it is already told that a state is represented as a rectangle with rounded corners. So there are how many states in this phone system? 1, 2, 3, 4, 5, 6 and 7. First one is dial tone. Dial tone, after dial tone, getting dial tone, there will be dial process and after that dialing. Dial invalid, it may be invalid or it may direct to the dial complete option. So if dialing is invalid, what it will show? It will show invalid number message. But if dialing is complete and it is correct, so that call will be connected. So this will go from dialing state to the connected state. And after that, if the call is connected, there may be two options. There may be two options. Receiver may be free or receiver may be busy. If receiver is busy, there will be some other state, that is busy tone state. If the receiver is free, there will be ringing state. Okay. After this, after the conversation will over, we hang up the phone, then that the phone system will be in the idle state, and after that pick up the phone, hold the free the phone, and after that if we want some another conversation, again pick up the phone. So this is the process of connecting the phone call, and in this diagram it is the behavior of the system is represented. Okay, and this is known as a state machine. Now grouping things. Grouping things, elements which are used for organizing related things and relationships in models. There is first thing is package. First thing is package. A general purpose mechanism, for organizing elements into groups. What is package? Package is a mechanism that organizes elements into different groups. So graphically, package is represented as a tabbed folder. Here in this figure, it is shown a folder and it is a tabbed folder. When the diagrams become large and cluttered, related are grouped into a package so that the diagram can become less complex and easy to understand. Now after this package, there is annotational things. Annotational things means a symbol to display comments. A symbol to display comments. Graphically, note is represented as a rectangle with a dog ear at the top right corner. So we can say that package is the only one grouping thing available for gathering structural and behavioral things. And annotational things can be defined as a mechanism to capture remarks, descriptions, and comments of UML model elements. So note is the only one annotational thing available. Here it is shown in the form of comment. Now, relationships in the UML. There are four kinds of relationships in the UML. One is dependency, another is association, generalization, realization. And these relationships are the basic relational building blocks of the UML. You use them to write well-formed models. So we will see it one by one. Dependency. A dependency is a semantic relationship. What is the difference between syntax and semantic? Syntax is the way of representation, and if we have represented the things, what is the meaning of that representation is known as the semantic. So in dependency, a dependency is a semantic relationship between two model elements in which a change to one element, that is independent one, may affect the semantics of the other element, that is the dependent one. And graphically, a dependency is rendered as a dashed line. So dependency can be represented in the form of dashed line, possibly directed, and occasionally including a label, as in figure. It is shown dependencies, dotted arrow line. Okay, so this is the dependency. Now association. An association is a structural relationship among classes that describes a set of links. A link being a connection among objects that are instances of the class. Instances of the classes. Aggregation is a special kind of association representing a structural relationships between a whole and its part. Graphically, an association is rendered as a solid line, possibly directed, occasionally including a label, and often containing other adornments such as multiplicity and end names, as in figure. So in this way association can be understood. So association, we can say association is a relationship between classifiers which is used to show that instances of the classifiers could be either linked to each other or combined logically or physically into some aggregation. Okay, so there are two terms, association and aggregation. So what is the difference? The question, what is the difference between association, aggregation and composition, is frequently asked in the examinations. So aggregation and compositions are subsets of association, meaning they are specific cases of association. In both aggregation and composition, object of one class owns objects of another class, but there is a subtle difference. Aggregation implies a relationship where the child can exist independently of the parent. Example, class parent and student child. Delete the class and the students still exist. Composition implies a relationship where the child cannot exist independent of the parent. Example, house and room. If room does not exist, separate to a house. Okay, so this is the example of composition. So in this diagram, in this figure, it is shown implier and implied association. Now the generalization. Generalization in the UML. A generalization is a specialization relationship in which the specialized elements means the child builds on the specification of the generalized elements, that is the parent. So the child shares the structure and the behavior of the parent. Graphically, a generalization relationship is rendered as a solid line with a hollow arrowhead pointing to the parent, as in figure. So this is the representation of generalization. We can say a generalization is a binary taxonomic that is related to classification directed relationship between a more general classifier, that is superclass, and a more special classifier, that is subclass. So because of this, generalization relationship is also informally called is a relationship. Okay. Now the next is realization. What is realization? A realization is a semantic relationship between classifiers wherein one classifier specifies a contract that another classifier guarantees to carry out. You will encounter realization relationships in two places: between interfaces and the classes or components that realize them, and between use cases and the collaborations that realize them. So graphically, a realization relationship is rendered as a cross between a generalization and a dependency relationship. Okay, this is shown in figure. These four elements are the basic relational things you may include in a UML model, and there are also variations on these four such as refinement, trace, include, and extend relationships are there. So according to the requirement, we use the include and extend relationships, refinements, and traces. So we can say that a realization relationship is a relationship between two model elements in which one model element, the client, realizes or implements or executes the behavior that the other model element specifies, and the other model element may be the supplier. Okay. Now the diagrams in the UML. A diagram is the graphical presentation of a set of elements, most often rendered as a connected graph of vertices and paths. Here we can say vertices means the things and the paths are the relationships. You draw diagrams and to visualize a system from different perspectives. So a diagram is a projection into a system. For all but the most trivial systems, a diagram represents an elided view of the elements that make up a system. The same element may appear in all diagrams, only a few diagrams, or in no diagram at all. Very rare case, the same element may appear in all diagrams. In theory, a diagram may contain any combination of things and relationships. In practice, however, a small number of common combinations arise which are consistent with the 5 most useful views that comprise the architecture of a software intensive system. For this reason, the UML includes 13 kinds of diagrams. So now I will take a break. In the next session, I will explain the diagrams which are used in the unified modeling language. Thank you.